Right Triangle Altitude Theorem in Geometry. In a right triangle ABC, with segment AD as the altitude for hypotenuse BC, there are 6 segments in this triangle, which are A, B, A, C, A, D, B, D, C, D, and B, C. Right Triangle Altitude Theorem relates the 6 segments in a right triangle with the altitude for the hypotenuse. The first relation states, AB square is equal to BD times BC. The second relation states, AC square is equal to CD times BC. The third relation states, AD square is equal to BD times CD. We can prove right triangle altitude theorem using similar triangles. Let's first prove relation 1. Since triangle ABD is similar to triangle ABC, we have AB over BC is equal to BD over AB, which can be converted to AB square is equal to BD times BC, thus we prove relation 1. Next, let's prove relation 2. Since triangle ACD is similar to triangle ABC, we have AC over BC is equal to CD over AC, which can be converted to AC square is equal to CD times BC, thus we prove relation 2. Lastly, let's prove relation 3. Since triangle ABD is similar to triangle ADC, we have AD over CD is equal to BD over AD, which can be converted to AD square is equal to BD times CD, thus we prove relation 3. In a right triangle with the altitude for the hypotenuse, if we are given any 2 segments, we can find the remaining 4 segments using right triangle altitude theorem and Pythagorean theorem. For example, if we are given the lengths of AB and CD, how do we find the lengths of the remaining 4 segments? Let's first find the length of BD. Let BD equal to x. Based on relation 1, we have a quadratic equation with variable x. By solving the quadratic equation, we can get the length of BD. We can then get the length of BC, which is equal to x plus q. Next, by applying relation 2, we can get the length of segment AC, which is equal to the square root of q times the sum of x and q. Lastly, by applying relation 3, we can get the length of segment AD, which is equal to the square root of x times q. So, by applying right triangle altitude theorem, we find all the remaining 4 segment lengths from the given 2 segment lengths. Next, let's look at an example problem. Please pause the video and read the problem. In this problem, there is a right triangle ABD with the altitude AF for the hypotenuse. Intuitively, we can apply right triangle altitude theorem to solve the problem. By applying Pythagorean theorem on right triangle ABD, we have BD square is equal to AB square plus AD square. It is given that AD is equal to 56 and AB is equal to 33. After substituting the values of AD and AB into equation 1, we get the length of BD equal to 65. Applying right triangle altitude theorem, we have equation 2, AD square is equal to DF times BD. After substituting the values of BD and AD into equation 2, we get the length of DF, which is 48.25. In summary, right triangle altitude theorem relates the 6 segments in a right triangle with the altitude for the hypotenuse. Right triangle altitude theorem can be used to solve geometry problems where a right triangle with altitude is available and 2 segment lengths are given or can be found. If you are interested in learning more math theorems or techniques, please visit our YouTube channel Maths in Minutes. If you like the video, please press the buttons of subscribe, like, share, and feel free to comment.